Okay, here's the chapter 1 study guide, just to help you out, a video for each of the problems here. So for number 1, you'll be given a question with 2 different functions here and evaluating different things. First thing they want us to do is f of 2. So we want to plug in 2 into the f function. So just be careful when you plug it in and work things out. So do our order of operations. So we have negative 2 times 4 plus 10 plus 3, which is a negative 8 plus 10 plus 3. So that gives us 5. All right, B, we're doing f of negative x. So that means we're plugging in negative x for x. So we're plugging in negative x here and also here. So negative x squared is negative x times negative x, which is positive x squared. 5 times negative x is negative 5x. So the answer is negative 2x squared minus 5x plus 3. All right, C, g of negative 11. So we're plugging in 11 for the g function. Negative 11 for the g function. So it's negative 11 minus 7, which is negative 18. Okay, for part D, we're doing f of x plus g of x. So we're adding these 2 functions together. So I'm going to line them up underneath each other so I have like terms. So here's my f. My g function I'm going to put right in the exact position where there are like terms. This is going to come down. So I have a 5x plus a 1x, so that's 6 x's. I have 3 minus 7, that's a negative 4. Can't add these together, that's your answer. For subtraction, for E, f of x minus g of x. So I'm going to put it over here. So I have negative 2x squared plus 5x plus 3, and I am subtracting x minus 7. So when I'm subtracting, right, this is going to become a minus. This is going to change to its opposite, correct? So I have negative 2x squared coming down. So I actually have a 5 plus negative 1, or 5 minus 1, so that's a 4x. And 3 plus a 7, which is 10. So this is my answer for E. Show using algebra if g of x is odd, even, or neither. So g of x is x minus 7. Let's write it down here. How do I show algebraically? I always want to replace it with a negative x, right? So I'm doing g of negative x. And I get a negative x minus 7. So now looking at this answer, I have to compare it to what was given. Well, it's definitely not the same. If it was the same, it would be even. Is each term its opposite? Well, this x became negative x. This negative 7 stayed negative 7, so it's not odd. So this answer is neither. All right, let's move on to number 2. Going to have a question that has a graph answering all kinds of things like that homework there that we had on Math Excel. It says answer the following questions. Okay, so we're doing 2 f of answers. So that means we're going to look on our x-axis. So f of negative 2. Here is negative 2. Where is this line cross at negative 2? Well, it's up here at 5. So this answer is 5. F of 5, we'll go to 5 on our x-axis. Where does this go cross on our graph here? It is at 4. All right, domain. What's my lowest x to my highest x? It looks like it's starting with a bracket, a solid dot at negative 2, comma, goes all the way to 5 over here, positive 5, again with a bracket. Range, my lowest y to my highest y. Well, my lowest y is at 0, right? Bracket 0. My highest y is up here, which is at 5. All right, now let's take a look at E. Find the values of x where f of x equals 0. So where is the output, the y, 0? Well, I see one here. This is at 0, 0. I see one over here. This is at 2, 0. So what are those x numbers? It's 0 and 2. All right, let's look at the next part. What is the maxima and minima point? Okay, my maxima is the highest that I could see here. Happens to be this one up here, so that's at -2, 5. My minima point, I got 2 of them, two lowest ones here. So I gotta write both 0, 0, and 2, 0. All right, moving on. What is the interval where the graph is decreasing? All right, left to right, you read it. So we got a couple of spots where it's decreasing. Is decreasing here. Is decreasing here. Those are the 2 spots that is decreasing. So when you are doing a decreasing interval, you always use your x numbers on the axis here. So where is it starting and ending at? All right, so this one's starting at -2 to 0. And it's also decreasing at 1 to 2. 1, 2. All right, I think that was it for that one. Let's move on to number 3 now. We are finding the domain of a function. So remember, there were 3 types. This is the one that's the fraction type. And we can't have 0 in the denominator. So we want to know what will make 0 in the denominator. We could have everything else, any real numbers, all reals, except what can't we have? So let's take out the denominator, make it equal to 0. We could add 16 to both sides, and we square root. Whenever you take a square root, we have 2 possible answers, which would be +4 and -4. So I could have all real numbers except positive and -4. So either way is fine, the way you write it. All right, number 4. Here we're graphing a piecewise function and answering the questions below. All right, so when we did this as a class, we set up a table. So the first one here that we're going to graph, let's do this in blue, is this one here. It's x plus 2, and we're going from -6 to +2. So I'm going to set up my chart here, x. I'm going to input it into x plus 2 and get my output for y. I'm going to start with -6. Let's do another number. Let's do 0 also, and then we're ending at 2. You don't have to do 0, but I'm going to. So let's plug this in. We get -4 for this one, so I'm plotting -6, -4. 0, so that's a 2. Here I'm inputting 2. My answer is 4. All right, now before we plot, let's see about our symbols here. Okay, so don't forget, equal signs means it's a solid dot. So on this point here that I make is solid. All right, so let's go ahead and plot this. -6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Here is -6, -4. Solid dot. 0, 2 is solid because it's in between both of those -6 and 2. 0, 2. And then for this one here, because it's got no equal sign, it's open. This dot here. So at 2, 4, it's going to be an open. 2, 4. 1, 2, 3, 4. Right here. Oh, shoot. I didn't do what I said. Open. And let's see. 1, 2, 3, 4. As best as I can. I don't have a ruler on this thing. Okay, so now I'm going to connect as best as I can here. use a ruler as best as you can, because they're asking for x and y intercepts. All right, so there is the graph for the first one. All right, now the next part says I want to do f of x equals, let's do this in black, f of x equals -7 if x equals 2. Well, here I don't even have an x to input anything in, so this is the one that I stressed is just a point on the piecewise graph. What point specifically is it? It's 2, -7. So let's go ahead and plot 2, -7. 2, 1, 2, 3, 4, 5, 6, 7 is right here. All right, third graph. And I will do this one in green. We are graphing f of x equals -x plus 9. So I'm going to f of x equals -x plus 9. X is our greater than 2. So that means when I set up my chart to get points to plot for this one, I have to start with 2. I know because of this symbol it's going to be open to start that line. And then I want all the numbers that are greater than 2. So let's choose a couple. So I'm going to let's choose 3 and 4. All right, let's input these numbers. So we have a -2 plus 9, we get 7. So this point is 2, 7. That's the open circle. -3 plus 9, 6. 3, 6. That's going to be solid because that line's going to go on forever in a direction. -4 plus 9 is 5. 4, 5. Okay, so we're plotting 2, 7 first. So I'm going to bring this up. 2, 7. 5, 6, 7. That one is open. And then the other 2 points, 3, 6, 4, 5, are solid because I need to know the direction that the flow of this line is going. 3, what was it, 3, 6? Yes. 3, 6, solid. 1, 2, 3, 4, 5, solid. So it is starting here and it is going in this direction. All right. Now, for some reason I don't have enough graph here. So if I extended this out, this will not happen on the test. You'll definitely have enough boxes for your graph for this. If I was to extend this out, because we need to know some intercepts here. Okay, my bad. All right, so let's go back to the A, B, and C. Finding the domain. Okay, so the domain for this one, what's my lowest x to my highest x? Okay, my lowest x looks like it's over here at -6, right? It's got a solid dot, so it's got a bracket. It keeps going to the left, to the right, to the right. Don't worry about these 2 holes because this thing down here fulfills it. And then it keeps going, keeps going, keeps going because of this green arrow. So that's to infinity. So -6 to infinity is the domain. The range. All right, is there a highest y, a lowest y? All right, so let's see. The lowest y, well, let's say we got -4 over here, but then we have a dot over here at -7. But then we have this green line coming down right over this direction, right? So it's going to be -infinity. And what's the highest y, the range? That one definitely has an answer here. It's looking like it's all the way up to the top, right over here, which was at 7. So -infinity to 7, that has a parentheses because it's an open circle there. So be careful about those domain and range. That was a difficult one. Finding x or y intercepts. All right, so I see a couple. Let's talk about x intercepts. I see one right here. And then I see one because my graph got cut off over here. So I got an x-intercept at -2, 0. And how much was this? 1, 2, 3, 4, 5, 6, 7, 8 at 9, 0. My y-intercept, I see 1, which is right here. This one is at 0, 2, 0, 2. And there are your answers for A, B, and C. All right, number 5, A and B are using transformations of parent functions. So on the directions, which you'll have to do on your test, there are going to be 2 of them just like this, is I need to see 3 points clearly. So let's first graph our parent function. So this is the square root of x minus 2. Well, what kind of transformation is going on when it's inside? That's left or right. It's the opposite of what we think. So here we're moving this graph right 2 units. Our parent function is the square root of x. If you forgot how to plot the square root of x, let's go ahead and choose at least 3 points, right? And I'm going to choose perfect squares. There are no negatives under the square root, so I'm using 0, 1, and 4, because 4 is a perfect square. So this one is going to be 0, this one is going to give me 1, this one's going to give me 2. So I'm plotting 0, 0, 1, 1, 4, 2. 0, 0, 1, 1, 1, 2, 3, 4, 2. This is my square root of x graph. All right, in the other color now, I'm going to move these 3 points right 2 units. So moving it right 2 units for all these 3. And here is my transform graph in red. Just like that is what you should be doing on your test. All right, last one for B. We have 2 different things going on here. We have a plus 3 in the inside, so that means left 3 units. And then we have a minus 2 on the outside of the function. That means down 2 units. So these are the 2 movements I'm using here. All right, what's the parent function? X squared graph. And again, if you didn't know any points, we could choose definitely some negatives and positives. All I need is 3. I'm going to do negative 1, 0, and 1. So negative 1 squared is 1. So these are the 3 points, negative 1, 1, and 0, 0, 1, 1, I'm plotting. This one, and here. So this is my parent function. All right, now let's do our transformation. I'll choose green. We want to go left 3 units, and then down 2. So here is where the vertex lands. Left 3, down 2. Left 3, down 2. Okay. There is my transform graph in green.